Um, can actually, I kind of changed my mind. Is it okay if I see you, one of you guys, doing the problem?
Yeah, sure.
Okay. I might feel a little more comfortable that way.
Okay. Yeah, we can do that. Okay. So, I actually can't find my drawing thing. Do you think you can start this off though?
Yeah,
Also,
okay.
did you start like the recordings and stuff?
Yeah, okay.
Okay.
So we're just gonna start on number one.
Yeah.
Okay. So number one, Erika worked 40 hours and earned $500. Letitia worked 50 hours and earned $600. How many more cents per hour did Erika earn than Letitia? So we just have to find how many dollars they earn each per hour. So for Erika, that will be 500 divided by 40. So this ends up being, gets rid of this, and then this becomes 25, 2. So 25 divided by 2, that's 12.5. So
So that would be our dollars per hour.
yeah, Erika. This is for Erika. And then now we look at Letitia. So she would have $600, and then she'll be working over 50 hours. So we can cancel this out, the zero out, and then divide both by 12. So Letitia would have $12 per hour. So how many more cents per hour? So Erika earns $12.50. Letitia earns $12. So Erika will earn 50 more cents, and that
Per
will be your
hour.
answer.
50 more cents per hour.
Right, 50 more cents per hour.
Um,
So 50 will be your answer.
so does that make sense? You understand how we got like their dollars per hour? We figured that out.
Yeah, I understand that.
Okay. Um, okay. So we can move on to the next question, I guess. So do you want us to like work all of these out, or do you want to try some of them on your own?
Um, can you, work all of them out?
Okay, yeah, I think we can do that. If that's good
Okay.
with you, Bill.
Okay, yeah, that's
Okay.
fine.
Okay. Or also like when we say like you work on your own for the poems, like um we don't mean like you work like totally on your own for like the whole poem and we just like say if you got it right. Like uh we can try to like work through the poem like with you, like at
Right.
the same time.
Yeah.
Okay. Maybe, I'll see.
Okay.
Okay. Okay, we can just work out this one, I guess. So there are 200 students at enrolled at Memorial Middle School. 70 of the students are in band and 95 are in chorus. If only 150 students are in band and or chorus, how many students are in both band and chorus? So, so for this one, you can think about if you add up, you know, your the given numbers of like how many students are in band and how many students are in chorus. You're gonna overcount by the number of students that are in band and or chorus, and you're gonna overcount by the number of students that are in both band and chorus. So then you would just have 70 plus 95. So that would be your sum of the students in band and sum of students in chorus. And then the difference, you're overcounting from the and or would be minus 150. And then if you just calculate that, you'll have like 165 minus 150, which is equal to 15. So that's your answer. But like So for this problem, do you think that like was this problem like familiar to you, or do you think like I worked like a bit too fast?
Um, uh,
Uh,
I
it, it
think it was, I think it was okay. I don't think you worked super fast.
okay. So it's okay uh if you don't like understand something, by the way. So we can help you with whatever you need help with. But I'll also show you like another way that I can do this. This way will help you like visualize the problem more, and this way might be like more intuitive for some people to think about. So we can make like a Venn diagram for the people in band and people in chorus. So boom, we have a Venn diagram. So we can say that the left circle are the people in band, and the right circle are the people in chorus. Yeah, what is chorus, by the way?
Like choir.
Don't you call it choir, not chorus? I don't
Oh,
know. Okay, so if you're saying like, so basically this Venn diagram, you have like people that are sorry, you have like people that are in band, right? Just in band and not in chorus, they would be in this group. Then you have people that are in band and chorus, they would be in that group. And then you have people that are just in chorus, not in band, they would be in that group, right? So if we have 70 students in band, that's saying like the whole circle will sum to 70 students, right? The whole left circle. Um, because like there are 70 students in total in band, right? And then 95 in chorus, that's saying like the whole right circle will sum to 95, right? Whoops, my tablet is being very weird. Um, okay, there we go. Yeah, so the sum of the left circle will be 70 and the sum of the right circle will be 95. And then it says 150 students are in band and or course. So band and or course would be this whole thing shaded, right? Because like if you're in band or if you're in course or if you're in band and course, you're all gonna be counted, right? So the whole Venn diagram thing would be counted in band and or course, right? So we can say like the whole Venn diagram thing will sum to 150. Um, wow, I can't. What my tablet is like glitching out. I can put it on here, I guess. So the whole Venn diagram thing will sum to 150. Okay, so if we know like this left circle sums to 70, and we know that the whole Venn diagram sums to 150, then like their difference. So like we can label like each of these areas as like variables like X, Y, and Z. So from like 70, we see that X plus Y is equal to 70, right? And then from the 95, we see that Y plus Z is equal to 95. Um, and then from the 150, we can see that or Bill, could you write this out? I can't write on my tablet for some reason.
okay. Do you want to keep explaining or?
Yeah, I can keep explaining.
Okay.
So yeah, from the 150, you can say that X plus Y plus Z is equal to 150. Very nice,
What?
X. Is it okay? And then now you just have like a system of three equations that you can solve, right? So you can take the third equation and then subtract it from the first, or subtract it by the first, right? And then you'll have like Z is equal to 150 minus 70. Um, can you write that, Bill?
Sorry, what?
Uh, so So you can take the third equation and you can
Mm-hmm.
subtract it by the first
Okay,
equation,
yeah.
and then you'll have z is equal to 150 minus 70, right? Which is 80. You can just
Yeah.
write 80, I guess. Okay. Okay, and then if z is equal to 80, then from like the second equation, y plus 80 is equal to 95. So then y would be equal to 95 minus 80, which is equal to 15. And then and then and then on the last equation you could just plug in y and z. So then, x plus 15 plus 80 is equal to 150. And then you can say that x is equal to 150 minus 80 minus 15, which is then equal to what,
55.
55?
Yep.
Yeah. Okay. And then oh, you wanted to know how many students are in band and chorus. So band and chorus would be the middle region, right? Which is y. And then so y is equal to 15, so that would be your answer. So once you figure out y, you can just stop there. So did that method make sense? And like, do you like that method more than the other one?
Um, yeah, that makes sense, and I kind of understood it a little better um when you did the second method, but um both of them were good.
Okay. Okay, we can move on to the next question. So, um, do you want to try to work this one out, or do you just want to let us do it? I can try again.
Um, uh, can you guys do this one?
Yeah, sure. So
Okay.
Dennis was playing Free Cell. If he completed one game every 5 minutes and won exactly 80% of the games he played, how many minutes did he stay at the computer to win exactly 80 games? So,
60 games.
oh, did I say 80? Okay, yeah, to win exactly 60 games. So he completes one game every 5 minutes, but every game that he completes, he's not gonna necessarily win it, right? He only wins exactly 80% of the games that he played, right? So um if you win exactly 80% of the games he played, and then you want to win 60 games, you can figure out like how many games you need to play to win 60 games, right? So like if we say the number of games that you play as n, then n times 80%, which is like your win percentage per game, n times 80% will give you the number of successful games, the number of games that you win, right? So, we can call the number of games that you win like W, right? So n is the number of games that you play, and W is the number of games that you win, right? And then n times 80% is going to equal W. So he wants to um, play games until he wins exactly 60 games, right? So with that, we can say W is equal to 60, right? So then with this equation, we can figure out what n is equal, right? We say n is equal to 60 divided by 80%, and then 80% is just like zero point 0.8, zero point 0.8, and zero point 0.8 is just going to be like 4/5, right? So then 60 divided by 4/5, that's just going to be 60 times 5/4, which is equal to 15 times 5, which is equal to 75. So this is telling us that Dennis will need to play 75 games um, to win 60 games. So we're going to find the time that he needs to play 75 games, right? And then it says he completes one game every 5 minutes, right? So if he needs to play 75 games, then the number of minutes he needs to it's the number of games he needs, sorry, the number of minutes he needs to play 75 games is going to be 75 times 5, which is just equal to like 350 plus 25, which is equal to 375. And then just wants in a minute, so this is going to be your answer. Um, so did that make sense?
Yeah, I understood it.
Okay, and um, how do you feel about like this algebra right here? If you can see my laser pointer.
Uh, yeah, I understand it. Um, it's, yeah, so, uh, I had a little trouble with it at first, but, I think I get it now.
Um, what did you have trouble with?
I mean, I was confused, um, but, like, I can't exactly say I just looked at it and I got confused, but, um, I understand it now.
Okay, okay, if you understand it now, that's good. But also um, again, like if you're ever confused about something, like even like in the middle while we're working something out, you can just call it out and we can address it. Um, and then you don't need to feel like that you can't like say anything, I guess. I don't know. But yeah.
O Okay,
So just let us know if you're like confused about anything, and then we can try to explain it.
okay.
Okay. We can move on to the next question.
It's
So do you want
7:58.
us?
Do you still want to keep going?
Oh, oh no. What do you think?
I mean, what do you think?
I don't know. I mean, I can say for this question.
Okay.
But okay. Okay. So for this question, do you want us to do it or do you want to try it?
Um, yeah, I'm not so sure about this one. Uh,
Okay. Okay. We can just go with it. So. Abe, Bobby, Charles, Devin, and Edwin are the participants in a race. How many different first, second, third place outcomes are possible if there are no ties? Two different outcomes to include are Bobby, Devin, Edwin, and Devin, Bobby, Edwin. So, so you have five people in a race, and we're looking for how we can order them into first, second, and third place, right? And then it tells us that first, second, and third place, it's gonna matter like who's in the first, second, and third place, right? It's not like in the example that they give us, like, if we're given a set of people, Bobby, Devin, and Edwin that are in first, second, and third place, that doesn't necessarily give us the most specific case. They want the case where like they're specifically ordered into first, second, and third place, right? So so you want to find the number of cases, the number of ways that you can order the people like that, and then you can just think about the people as like um, the letters A, B, C, D, and E, right? Like the start of their first names, because that's how they do it. So so you can think about like first, second, and third place as like three three places, and then you can think about how many ways how many ways can I order people into each of the places? So like you can first think about like um how many how many choices, how many ways can I put one person into first place and then choose one of them